Most people have heard of mantis shrimps. They're a pretty wicked animal after all, and there are countless tales of what they are capable of. People know it as the thing that can use its punch to break through titanium and cause nuclear explosions, and the creature that has eyes which can see into different dimensions and other stories like that. I don't think the mantis shrimp can do any of those things, unfortunately, and I doubt they'll be doing any of them anytime soon, but they are still very interesting creatures and very cool, and they do test the boundary, or push the boundary for what's possible in the animal kingdom. And actually, they do teach humans a lot about what we can do as well, so they are a very useful and very interesting animal. So what is it? Well, it's a marine crustacean, but it's not a shrimp, and it's not a mantis either, by the way. It's in its own order, called the Stomatopoda. So this is a phylogenetic tree of the Malacostraca, which is like the largest class of crustaceans. It includes things like the Brachyura at the top, or basically the crabs, and the Anomura, which are basically the hermit crabs. It's kind of crowded, but at the bottom you can see the Stomatopoda, which is the mantis shrimps. You'll also find orders comprising the lobsters and isopods and whatnot. Across the globe, there's around 451 mantis shrimp species, and some of them are right there in that picture. They're usually found in warmer tropical areas and coral reefs, but you can find a few species in more cool, temperate seas. Most of the mantis shrimps are they're fairly small crustaceans, no larger than 20 centimeters, although on some occasions you find some certain species like the zebra mantis shrimp, which is a ridiculous creature that can achieve lengths of like 46 centimeters at a max. They are a pretty essential part of many marine ecosystems, especially those around shallow reefs where there's an abundance of prey. In general, there's considered to be two variants of mantis shrimps, and it depends on their raptorial claw and how that's modified. You essentially have the clubbed mantis shrimps with a calcified, robust dactyl, and the spear mantis shrimps, which have a very pointed and serrated sort of raptorial claw. So in general, the two variants, they do actually have quite a varied behavior. The robust dactyl of the clubbed mantis shrimps allows them to tunnel into rocks and corals and make burrows in there, whereas the spear mantis shrimps, they prefer to dig into finer, softer sands and sediments and make tunnels in there. They lack that reinforced, calcified dactyl of the clubbed variant, and so they can't really break into harder surfaces as easily as they can. And so tunneling into this sand is a lot more efficient. They are highly elusive creatures, and they spend most of their lives in those burrows. There's some species like this guy here, they're more active than others, though they still do retreat to their burrow when feeding or mating. So this form here, this is a spear, and it presents with a set of raptorial limbs that spear and hold soft-bodied prey before dragging it into the mantis shrimp's burrow. And then the other variant presents with that club that it uses to burst open the harder outer surfaces of clams and crustaceans and other hard-bodied animals. You can see on this club variant of mantis shrimp that the dactyl there labeled D has a spear tip on it. It's a very small spear tip, but it can use this to a certain degree, but nothing compared to the counterpart here, the spear mantis shrimp, which has a much more developed raptorial claw for grasping and holding on to prey. The clubbed form of mantis shrimp is notorious for being able to launch its arms out at a reported speed of around 83 kilometers an hour, which, when impacting its victim, would generate a peak of around 1,501 newtons, according to a study done on the peacock mantis shrimp. Though in fact, each strike actually delivers 2 impact forces, The first being the actual club hitting the target, right? And then the second being the force delivered after the collapse of a cavitation bubble created by the sheer speed of the peacock mantis shrimp's attack. And this cavitation bubble, when it collapses, when it implodes, it generates a force of about 500 newtons at most, and releases heat, light, and sound on top of that initial 1,500 newtons from the actual impact of the club. On the other hand, the spear variant has a preference for softer-bodied prey like fish, and they use that raptorial claw to simply grab, impale, and hold their prey. Now, this is just a personal opinion of mine, but I don't think that the smashing ability of the mantis shrimp is the most interesting thing about this animal. It's its eyes. I might be looking too deep into this, but those two little eyes that put everything else in the world to shame, they really make you question about how complete your understanding of reality really is, and how true what you think is true might actually really be in reality. On the more antero-superior position of the mantis shrimp's thoracic carapace, we find two dangly stalk things that move independently from one another. And atop those dangly stalk things is a pair of the most advanced visual systems that we know of in the animal kingdom. Humans, as developed as we are, generally only have around 4 pigments. Rod cells have one of these pigments for dim light exposure, whereas cone cells have 3, which are used for detecting color when there's more light exposure. The mantis shrimp, on the other hand, they can have up to 16 pigments, 12 of which are used for detecting wavelengths of color. Of these 12, 6 are sensitive to ultraviolet light. The remaining 4 pigments of the initial 16 are used for analyzing polarized light, which is light that oscillates uniformly along a constant plane. And to take it to an even greater extreme, 6 species, Gonadactylaceus falcatus, Gododactylus smithii, Haptosquilla trispinosa, Odontodactylus scilaris, and Odontodactylus laterostris, and of course the Lysiosquilina maculata, the zebra mantis, can all detect circular polarized light. And curiously, the Haptosquilla trispinosa is more sensitive to an elliptical form of polarized light. No other known animal can interact in this way with circular polarized light. One of the species, Gonadactylus smithii, goes a step further and can detect the 4 linear and 2 circular configurations of polarized light required for essentially a complete vision of all polarized light. Some certain mantis shrimp species can even alter the sensitivity of their vision in regards to lower frequency light. This ability appears to depend on the varying intensity of light exposure, otherwise known as the photic diversity, of the original habitat in which the species is found. The mantis shrimp can analyze a very diverse array of wavelengths. However, their ability to distinguish wavelengths less than 25 nanometers apart is very poor. This appears to reduce the delay of processing visual stimuli by making the information more, digestible, more efficient to process. The eye of the mantis shrimp can be separated into 3 regions, 2 large hemispheres that are separated by a third area that looks like a band composed of 2 to 6 specialized rows of photoreceptor cells. The mantis shrimp can therefore see the environment with 3 parts of the same eye, giving it trinocular vision and depth perception. And it has to be good at depth perception since it needs to grab prey with those modified raptorial claws. A simplified and generalized structure for mantis shrimp eyes can be seen in this way. 6 rows of specialized photoreceptive cells in the midband. Of these, rows 1 and 4 can use 8 visual pigment classes as well as color filters, in complex structures to detect wavelengths from deep ultraviolet UVB, which is 280 nanometer wavelengths, to far red, which is 720 nanometer wavelengths, thus giving it the ability to process color in an enormous range. Rows 5 and 6 have a specialized 9th pigment class for detecting polarized light, and the upper and lower hemispheres of the mantis shrimp's eyes that are separated by the midband have a 10th pigment class. And look, I really don't know if I'm looking too far into the mantis shrimp's visual ability, but it's something that, for whatever reason, has always stuck with me and filled me with a nostalgic sense of wonder. Just from looking at these creatures, you can tell that they really are out of this world, and when you get to examine their behavior, well, you immediately realize the quick, cunning intelligence that they possess. I personally get the feeling that they see a world beyond what we can ever hope to imagine. Something really special. Their reality is removed from that which we can see ourselves. A different existence entirely. There's even a species of mantis shrimp, Nanosquilla decempspinosa, that, when stranded, turns into a wheel and rolls around until it finds a body of water. And if you look closely at the picture, you can even see that it's a spear mantis. Look at the raptorial claw if you can see it. Anyway, that's pretty much all I can think to cover in this video. If you want more specific content, just leave a comment and I'll probably see it and consider making whatever it is you ask for, if it's appropriate for this channel, you know. I'm sorry about the echo and the weird mic. I don't really have very high quality equipment or anything. This is about as good as it's gonna get. But anyway, subscribe and stuff if you like mantis shrimp.